Last week, I think we finished here with until this part, discretization. What is discretization? It's a concept. Discretization means we want to divide the range of a continuous attributes into intervals. So you already know that we have three kind of attributes. Actually we have two attributes. Okay. The first attribute is numerical or continuous, and the other attribute is categorical. And in the categorical, we can have nominal, ordinal, and binary. So among those three, so the attributes we can have like the nominal and ordinal for the discretization. Nominal, we know that it is a value from the unordered set. Unordered. Nominal is from unordered set. Ordinal, we have order. Order means we have the sequence. And the numeric, of course, you know the numeric is real numbers, integer, or whether it is the real numbers. So the discretization, we want to divide the range of continuous attribute into intervals, so we can have the interval labels that can be used to replace the actual data values. Maybe we have the age. We just specify the age is 25, but we are not sure what is the meaning by 25. We can replace something with a value, maybe young. So it is more meaningful, or we can say, this is, we have the interval level. Young, it is the age between 20 until 40, for example. Because this is the interval labels. And we can reduce the data by the discretization. If we have the data like 25, we have another data like 35, we have another data like 38, 39, 42, 44, and so on. So we have too many data that we want to analyze. So if you classify it, or if you make it into intervals, okay, 20 until 40 is young, and then 40 until 50 is adult, then you can make it a smaller values. Or we can reduce the data size. And it is related to supervised and unsupervised. So we will learn more about this supervised and unsupervised. And split and merge. So top down and bottom up. Discretization can be performed recursively on attribute. And it will be prepared for further analysis, for example, the classification. So the typical methods for the data discretization is you can use pinning. Pinning. We can have the equal width, equal frequency. Histogram analysis. So if we use the pinning, it is the top-down split. We have the data, and then we set how many intervals or how many bits do you want. That's what we call as top-down, because we need to determine. And it is unsupervised. Unsupervised means, we do not know what are the labels, what are the category. So we just want to split based on some values. We can also do histogram. The histogram analysis is also top-down and it is unsupervised. Because when you create the histogram, you can also find the width. And the width is different if you select it in different numbers. For example, in the file, let's say I use the iris data. When you use this iris data and you use the distribution, if it is the categorical data, yeah, it will show you the frequency. But if you have the numerical data, now you make it as a discretized. And this will depend on the bin. That's why we call this unsupervised. And it is top down. It depends on how you define this bin width. If this bin width is 0.5, then this will be the distribution, or this will be the interval. If you change this bin width into 1, then this will be the interval. If you change this bin width to 2, then this will be the interval. So it depends on us. This is the top down. Clustering analysis, it is unsupervised, top-down split or bottom-up merge. And yeah, we will learn the clustering analysis and decision tree analysis later on. We already learned the correlation or chi-square analysis. So please check your materials. I think in the materials I put unsupervised. But in the correlation analysis, yeah, we can mostly is for the supervised. Even though we can do it the unsupervised, but later I will explain to you why it is supervised. So I think in your material it is still unsupervised. Please update it. And it is more the bottom up. What is the difference between binning and clustering? So later we will learn more about the clustering. When you do the binning, you can have something like this one. So I have this data, the blue, the green, the light blue, the yellow and red color. So I want to make it as a 3-bin. So the 3-bin is more about the intervals between the data. So we have this because it is more dense, and this will be the other bin, and this will be to place the data in the red. But when you do the clustering, so they will have the mid value is this one, mid value is this one, and the mid value is this one. So they can make a better category with the clustering instead of the binning. So we will learn more about this kind of way to do the discretization. We can have the discretization by classification and correlation analysis. Classification. One method that is good for the classification, we call it decision tree analysis. So it is a supervised. We have the class label. So what does it mean by class label? We will learn more. But for example, this one is from the medical. This is from the health. Maybe we are not doctor, so it is difficult. But there are some data about the medical, like tumor. The doctor should be able to distinguish whether the tumor is dangerous or not dangerous, or we call it the cancerous or malignant. Cancerous means malignant, it is dangerous. So it is the cancer. But benign is just a tumor. So in order to make this kind of classification, the doctor should measure many things. Maybe from the blood test, maybe from the many tests from the patient. And based on those data, they can classify whether the tumor is benign or malignant. We call this is classification. We can classify based on data. And this is top down because we need to get the observation and we need to give the data to the doctor. So the doctor should be able to detect, okay, this is cancerous, this is not cancerous. And once we have the data, we can train it later. And we can make this discretization. Later we can do the iteratively recursive split. So we can build the decision tree and it can be the decision tool for the doctor. We will discuss it later about the classification. The correlation analysis. The correlation analysis or the chi-merge or the chi-square based discretization, we can say it is the supervised because we will use the class information. We can say this is the bottom merge because when we have some data in the bottom or we have the numerical data, usually the numerical data is the bottom up or the bottom data or the lowest data. And we can find the neighboring in the whole. So if they are similar in the distribution, we will merge it. The similar distribution means the low chi-square values. And the merge perform recursive until we have some optimal function. The correlation analysis, we want to analyze based on the numbers between some categorical values. So if it is low, there is no correlation. If there is no correlation, then we can try to merge. So if we merge those data, hopefully we can increase some values about the correlation. Another concept about the discretization is about the concept hierarchy generation. The concept hierarchy generation is to organize the concepts. What is the concept? It is the attribute values. And we want to perform it hierarchically. And it's usually associated with each dimension in the data warehouse. Concept hierarchies facilitate drilling and rolling in data warehouse to view the data in the multiple granularity. So the idea is drilling and rolling. Sometimes they call it roll up or drill down. What is the meaning? Drill down, roll up. Based on this word, we can see, for example, we have the data Q1. Q1. So I want to drill down. I want to make it in detail. So I can make the January, February marks as the representative of the Q1. So I want to drill down. Or I can roll up. Roll up means I want to get the higher level. Let's say I have the data I have the sales data in New York, Chicago, Arizona. So those cities are in USA. Then I will put in the upper level. So that's why we call it the upper. And drill down is go to the lower level. We have concept hierarchy formation. It will recursively reduce the data by collecting and replacing the low level concepts by higher level concepts. So as I mentioned before, we have the numerical values. What is the numerical value? For x, 25, 20, 30. We can represent with the higher level. What is the higher level? Maybe we want to make the category youth, or we want to make the category adult, or we want to make the category senior. So this is the higher level. And the low level is the numerical value for it. There can be many examples for this concept hierarchical formation. Another example is for the nominal data. Concept hierarchical generation for nominal data. The previous one, it is the concept hierarchical generation. We can have based on the numbers, based on the numerical values. If it is based on the nominal data, then we can see the order of attributes, specification of an ordering of attribute explicitly at the schema levels. And it is based on the users or based on the experts. For example, I know the city, and the city belongs to a state. And then I know that state belongs to a country. Maybe the lowest level is the street. We live in the Vedero. Vedero is the street. And then the city is Yongin. And Yongin is in the Gyeonggi province. And Gyeonggi province is in the South Korea. So we call this is the hierarchy. This is the concept hierarchy generation. Sometimes we have the specification of hierarchy for a set of values by explicitly data grouping. Maybe this example is Urbana, Campaign, and Chicago. They are in the same state, which is Illinois. In our case, in Korea, maybe you know in our city, Yongin, we have Sujigu, we have Cheongu, we have Gyeonggu. Okay. So those three are in the districts of Yongin City. Okay. So we can make a set of values. This set of values is in the same level. But district Suji, district Yongin, and we can make specification only a partial set of attributes. So I just want to see only street and the city. So maybe I just want to see the Vedero. So we live in the Vedero. And then, yeah, I know that this street is in the Yongin. But in Yongin, there are many other streets. So I just want to focus only one because it is the partial, only some, not all. So we can make the automatic generation of hierarchy. We can have the attribute level by the analysis of the number of distinct values. So if we have the number of distinct values for every of this set of attributes, for example, street, city, state, country, and you will have many values, so you can automatically generate the hierarchies. For example, I can make the values like this one. Where, comma, it is in the Yongin city, it is in the Gyeonggi province, it is in Korea. Okay. If you look at this one, we have in the same level. But here we have different level, and we want to check the difference between the data. Maybe this is Yongin, Gyeonggi, and Korea. We can set another data. Let's say, what is another? Hoandero. Okay. So it is also located in Yongin, in the province of Gyeonggi, and it is in the Korea. So we can have another row, okay, in Yongin, and it is in the province of Gyeonggi, and it is in the country of Korea. So if we place these values, so it is unique, distinct, because it has different street. And if they have the different street name, we got this distinct values. So if we have a lot of these values, we can make the hierarchy generation automatic. So that's why when you put your address in like Kupang or any kind of website, if they ask where do you live, so you can just mention the street. When you mention the street, it automatically show the city, it automatically show the state, and the numbers that the road where you live. So they use this automatic generation of hierarchies. So the automatic concept hierarchy generation, some hierarchies can be automatically generated based on the analysis of the number of distinct values per attribute in the dataset. So some hierarchies we can automatically generate like this one. Maybe in the country level, let's say maybe in Asia. In Asia, we have several countries, maybe like Japan, China, Korea, India, Singapore, Malaysia, and so on. Maybe let's say we have 15 countries. In those 15 countries, of course, they have province or state. So we have more distinct countries. In 15 countries, they have many states. And then in this state, they have many cities. So it's more numbers on the cities. And in these cities, we have many streets. So it is more. So the lowest level will be the highest number of values. The attribute with the most distinct values placed in the lowest level. So this is the lowest level. But sometimes it does not work with this hierarchy. For example, if you use time, if it is related with time, it is sometimes doesn't know, because some of them may be overlap. For example, if you want to consider month and quarter, month and quarter is overlap. Q1 contains of January, February, and March. Okay. So you cannot say January, comma, Q1. So it is not unique. Weekday. Weekday is like Monday. One, maybe for example, comma, January, comma, Q1, comma, 2022. So it will have some not distinct value. So here we want to get the distinct values. Okay, learning check. What is discretization? Okay, so transform the numerical values or numerical data into intervals. Okay, and these intervals, or I can say some categories. In other cases, when we learn about the concept hierarchy, we can also transform the nominal data into different hierarchy or different levels. So if it is in the street is nominal data. We can make it the higher level district. We can make it a higher level city. We can make it a higher level country. So the discretization, it can be also in the different levels. Can you mention some of the data discretization methods? Okay, good. We have binning. We have clustering. Okay, so we will learn more later about the clustering. We have classification. Okay, and then we have the histogram analysis, and we have the correlation. Okay, so those 5 you can see from the previous PowerPoint. So what is the difference between equal width and equal depth? Yeah, it is the binning. So what is the difference? Equal width and equal depth. This kind of question might be in the quiz. The equal width means we want to make it the data into the same interval. But equal depth is to discretize based on the equal frequency. Okay. You can check from the previous materials. In the concept hierarchy generation, there are 2 concepts: drill down and roll up. What is the difference? Drill down is? Okay, the drill down is to make it more detailed, and roll up is to merge, or we want to make the summary, or we want to find the upper level based on the hierarchies. Okay. So let's see the examples in orange. I can make discretize. Okay, discretize. As we know that we want to make the numerical attribute into interval or into some category. And in the default, we have the equal frequency, equal width, or you can leave the attribute as numeric, or we can do the entropy. So I didn't explain this entropy. We can remove the numerical attributes, or we can make some data in a manual way. So let's say I want to make it as an equal frequency, and the number of intervals are 3. And if you generate this one, every data, every numerical data, it will be in a 3 different level. So the data of this one is below 5.45. This data is in between 5.45 until 6.35. So if you go down, there will be some data which is higher than 6.25. Okay, this one is the data higher than 6.25. So they have 3 categories because we select the intervals equal to 3. You can define these intervals. Maybe, okay, for the sepal length, I do not want to use equal frequency. So I want to use the equal width. You can change in this individual attribute setting. If the attributes use the default means the upper side. But if you want to make individually for every attribute, you can select the attribute first and then select what methods you want to use for the discretization. Let's say for the sample length, I want to make it as interval 5 with equal width. Maybe for the petal length, I want to remove it. Okay. And then for the petal width, I want to leave it as numeric. Okay, just example. So you can see the result. So the petal length has been removed. We do not include it. And then the petal width is in still number. But the sepal length, now you will see that it is in the 5 different levels. Below 5.2, between 5.02 until 5.74, between 5.74 until 6.6, and so on. So this is the discretize. The other things that we can learn is the continuous. What is continuous? Continuous means I want to, if discretize, it is to transform numerical data into categorical data, but continuous is the opposite. It is to transform the categorical data into numerical data. Okay, is the opposite. So the function in the continuous, there are some functions like this one. You can use the categorical features So they have so 1, 2, 3, 4, 5, 6, 7. Okay, 7 methods. But we can also continuous the numerical features. What does it mean? If you still remember, this function is from the normalization. We want to change the numerical features with the continuous. For example, I want to normalize to interval, or I want to normalize to 0 and 1. We can also have the categorical outcome. Okay, the categorical outcome means if it is category, I can make it as numbers. We can treat it as ordinal. We can divide by the number of values, or we can have the class per value. So we will learn more later about the other functions. But let's suppose I use the first value as base. Maybe for this one, I will make another data. I think you still remember the Titanic data. Okay. In the Titanic data, I want to continuous. So this is the result of the continuous. Maybe I will compare. Can you see the difference? In the original data, we use the category. So first data, the data number 1, it is yes, and then we have the data is first for the status, and then age is adult, and sex is male. But now we change into number. The column status equals to first, it will be 1. The status equals second will be 0. The status equal to third is 0. What does it mean? I know that this status is first. So the column status equal to first will be 1, and the remaining will be 0. Okay. What about the age? Age adult. We have age equal to child, and it is 0. So it means the age is child is 0. It means it is adult. What about the sex? Sex male equals to 1. Then it is true that the sex is male. Why do they use this one? If you look at the data, age and sex, we have only 2 values. So if the age equal to child, then of course it should be 1. But if it is not child, then adult will be 1. Because we have only 1 column, we have only 1 column, which is age equal to child. Okay, we have only 1 column, which is age equal to child. So it has the value either 0 or 1. If the age child is 0, then it means the age is. Let's see. okay, the row 320. Okay. The row 320. You can see h equal to chart equals to 1. This one equals to 1 and the h is chart. Okay. When it is chart, then it equals to 1. When it is adult, it equals to 0. Okay. Then we can have all the values from this categorical into this numerator. We call this the continuous. Okay, so we just learned the basic one, okay, about the continuous. We just learned the first value as the base. We will learn more about the other things in a few weeks later. So we learned about the data reduction, dimension reduction, numeric reduction, data compression, and the data discretization. We learn about the transformation by normalization, and we learn about the concept hierarchy generation. So the quiz, I think you need to learn until this chapter. Okay. We still have some time. Let me just give you some introduction about this chapter. So this chapter is about similarity and dissimilarity. Similarity. It is a numerical measure of how alike two data objects are. The value is higher when objects are more alike. And it often falls in the range of 0 and 1. So it means if it is 0, it is not similar or different. If it is 1, it is similar or the same. Okay. This is based on the similarity. Value is higher when objects are more alike. What about dissimilarity or distance? The dissimilarity, or we can say distance, it is a numerical measure of how different two data objects are. Okay. This one is to check the different, this one is to check the alike. Lower when objects are more alike. So if it is 0, it means more alike. Minimum dissimilarity is often 0. If we call minimum dissimilarity, it means it is the most similar. But the upper limit varies. It means it can be like infinite. The distance can be 10, or the distance can be 100. The distance can be 1000. So it depends on the data. And when we are dealing with this similarity and the dissimilarity, we can use the word proximity. Okay. It refers to similarity or dissimilarity. Okay, I guess it's the time.